Welcome to the 3Dflow Academy. In this video, we'll cover control points and ground control points in 3DF Zephyr. We'll clarify what they are, how they differ, and why they matter. In 3DF Zephyr, it is essential to distinguish between control points and ground control points. A control point is a point defined inside the project, either by marking the same feature across multiple images or by picking a point directly on the 3D model, with coordinates expressed in the local reference system of the Zephyr project. The more accurately a point is marked across the images, the more reliable that control point will be. At this stage, the point may only exist as an image-based reference inside the project, not linked to real-world coordinates. Once a control point has been marked across multiple images, Zephyr records its 2D image coordinates, x and y, across each view. During camera optimization, these image observations combined with the control point's known 3D position are used in bundle adjustment to refine camera poses and improve consistency between the estimated geometry and the image data. Control points can be used to set scene scale if at least one real-world distance between two control points is known and measured on site. It's worth pointing out that control points can also be used for other purposes, such as CAD drawing, section generation, contour lines, or to support the generation of orthophotos and orthomosaics. A ground control point is a control point with known 3D coordinates, typically measured on-site using GNSS receivers, total stations, or similar survey instruments. Once those coordinates are assigned by the user, ground control points can be used to scale, georeference, and constrain the project to a real-world reference system. Zephyr allows ground control points to be set either as constraints or checkpoints. This distinction is important because the same type of point can play different roles inside the project. The difference is not in the nature of the point itself, but in how it is used. A constraint is a ground control point that is used actively during bundle adjustment to optimize camera positions. This gives users stronger control over the reconstruction and helps reduce the difference between the estimated geometry and the surveyed reference data. A checkpoint is a ground control point that is not actively used during bundle adjustment. Its coordinates are available inside the project, but they are not used to drive the camera optimization. Checkpoints allow the user to monitor the metric error between the 3D model and the surveyed reference data without influencing the camera optimization itself. This makes checkpoints useful for the purposes of validation. Bundle adjustment is the algorithm behind the camera optimization process that refines camera positions and scene geometry by minimizing reprojection errors. It is recommended to run bundle adjustment before generating dense point clouds or meshes because it modifies camera positions and orientations at the sparse stage. If dense clouds or meshes are already present in the project, they will be removed and must be generated again after the optimization. After scaling and georeferencing, the result is typically a lower metric error and a lower reprojection error compared to the initial camera solution. To properly set your GCPs in Zephyr, use the Align Model with 3D Constraints dialog. After importing a text file containing the GCP coordinates, you can enable the corresponding flag in the CS column to use a ground control point as a constraint, or in the CK column to use it as a checkpoint. It's worth pointing out that control distances can also be defined as constraints, and the same applies to camera geographic coordinates, as in the case of drone imagery, although it's preferable to set them as constraints when they come from the RTK or PPK systems, since they are much more accurate than standard GPS coordinates. In fact, when you process images with RTK or PPK coordinates, Zephyr automatically sets those coordinates as constraints. A good ground control point should be clearly visible, easy to identify, stable, and visible across multiple images. Good candidates include targets, painted markers, or sharp features with clear contrast, such as the corner of a building. Poor candidates include blurry areas, uniform or reflective surfaces, vegetation, moving elements, or vague edges. This matters because a ground control point is only useful if it can be marked consistently across images and if its surveyed coordinates are reliable. GCP quality is important, but distribution is also critical. If all ground control points are concentrated in one small area, the project is strongly controlled only there. Other parts of the reconstruction may remain weaker. For best results, ground control points should be distributed across the scene as evenly as possible. If the project includes height variation with significant depth changes, the point distribution should reflect that as well. A few well-distributed ground control points are often more effective than many points placed too close together. And that completes our overview of control points and ground control points in 3DF Zephyr. If you have any doubts or questions, please feel free to contact 3Dflow technical support at support@3dflow.net.